There is something called the thermodynamic hypothesis of protein folding. Just to be clear, since there are many hypotheses that were posed in the development of the field or the study of thermodynamics, but the thermodynamic hypothesis of protein folding is as follows. The native structure of a protein is determined solely by the intrinsic properties of the protein sequence and not by an external template. Who wants to try to explain what that means? In different words than it is exactly there. Yeah.
All of the information required for folding is in the sequence.
Perfect. All the information that the protein needs to fold up is contained in its sequence. That's where all the instructions lie. That's exactly right. An individual protein will adopt its native structure, and its native structure is considered to be whatever conformation it would be in under normal physio conditions. So what were some of the things that are normal physio conditions? Yes, Jerry?
Like pretty neutral pH.
Right, we're right around neutral pH, we're about 7.4-ish today.
Body temperature.
We're at body temperature, great, 37C. And we're in water, I think those are the only ways we really defined it. We're at, our pressure is like atmospheric pressure. But right, so when we're in normal physio conditions, this is the conformation the protein would be in. And it would fold up that way spontaneously, which we already defined as being net negative energy is how this would happen, okay? So it's energetically favorable to be in its native state. Similarly, protein complexes would fold and assemble spontaneously without help of external agents. So this is talking about quaternary structure here. So even if we have multiple subunits of some sort of complex of proteins, they could also assemble themselves. The instructions are there for the interactions between them. There's an exception to every rule, of course, sort of. So, and that's in the form of molecular chaperones. Molecular chaperones are protein molecules that can help other proteins fold properly. It doesn't mean that this protein that needs help doesn't already have the instructions. It does. But it means that this protein that needs help probably has a lot of hydrophobic groups, and as it starts to fold, sometimes the hydrophobic groups, as they're exposed to the polar environment, start to aggregate and interact with each other in a way that can lead to some, like I said, non-specific clumping, aggregation, unfolded regions, and just some sort of stuff you don't want to happen, okay? They might be able to fold totally properly on their own and none of this aggregation crap will occur, but they have the instructions that they're more likely to have problems during folding, and so a molecular chaperone would come in and facilitate.